The dangerous stakes hook. Have you ever wondered why your hairdryer doesn't ignite the second you flip the switch? It's all thanks to a hidden dance between airflow physics and tiny thermal fuses. We are tearing one apart to expose the incredible engineering that stabilizes catastrophic heat levels in under 3 seconds, keeping your grooming routine from turning into a disaster. You plug in your hairdryer. It instantly blasts super hot air, inches from your head, next to your hair, inside a plastic device, yet somehow it doesn't burst into flames. But here's the crazy part. Inside that little hairdryer are several hidden engineering safety systems working together every second to stop it from turning into a mini flamethrower. And if even one of these systems fails, things can go very wrong. Today we're going to break down the hidden engineering inside hairdryers, the 3 safety systems preventing fires, why some hairdryers overheat and burn out, and the simple mistake many people make that destroys them. By the end of this video, you'll never look at a hairdryer the same way again. 1. The heat inside your hairdryer. First, let's understand something surprising. Hairdryers can reach temperatures of over 140 degrees to 160 degrees. That's hot enough to melt certain plastics, burn skin, damage electronics, and potentially start a fire. So how does a small handheld device manage that heat safely? The answer is controlled heating engineering. Inside your hairdryer is something called a heating coil. This coil is usually made from nichrome wire. Why nichrome? Because it can handle extremely high temperatures, resist burning, and maintain stability under electrical load. Electricity flows through this wire. It resists the current and converts electricity into heat. This process is called resistive heating. But here's the catch. Without airflow, that heating coil would glow red hot and destroy the dryer in seconds. Which brings us to the next critical system. 2. The airflow cooling system. Hair dryers don't just heat air. They force air across the heating coil. Inside the dryer is a small high-speed electric fan. This fan pulls cool room air in through the back vent and pushes it across the hot coil. That moving air does 2 things. 1, it carries the heat outward toward your hair. 2, it prevents the heating coil from overheating. In engineering terms, this is called convective cooling. Without it, the heating coil temperature could rise to dangerous levels within seconds. That's why if airflow gets blocked, the dryer suddenly overheats. And that leads to one of the most important hidden safety devices. 3. The thermal fuse, your dryer's secret bodyguard. Inside almost every hairdryer is something called a thermal fuse. Most people have never heard of it, but it's the last line of defense against fire. A thermal fuse is designed to break the electrical circuit if temperatures exceed a safe limit. Think of it like a safety sacrifice. If the dryer overheats, the fuse burns out permanently and shuts off the device. That's why sometimes a hairdryer just suddenly dies and never turns on again. It's not always broken. The thermal fuse saved you from a potential fire. 4. The bimetallic thermostat. But the thermal fuse isn't the only protection. Hairdryers also contain a bimetallic thermostat. This device acts like an automatic heat regulator. It works using 2 metals bonded together. Different metals expand at different rates when heated. So, when the dryer gets too hot, the metal strip bends and cuts power to the heating coil temporarily. Once the dryer cools down, the metal straightens again, and power turns back on. This cycle repeats many times per minute while you're using the dryer. Without this system, the heat would spiral out of control. 5. Why hair dryers overheat. Now here's something most people don't realize. Many hairdryer failures are caused by a simple mistake users make every day: blocking the air intake. The back vent of your dryer is extremely important. It allows the fan to pull in cool air for circulation. But if this vent gets clogged with hair, dust, lint, bathroom debris, airflow drops dramatically. That means the heating coil isn't being cooled properly, and temperatures start rising quickly. This triggers the thermostat repeatedly. Eventually, the thermal fuse blows permanently, and the dryer stops working. 6. Another hidden protection: flame-resistant materials. Hair dryers also use special flame-retardant plastics. These plastics are designed to resist melting, prevent ignition, slow the spread of flames. Many dryers are made with UL-rated heat-resistant polymers. That means even under extreme heat, the housing won't easily catch fire. This is another layer of engineering protection most people never notice. 7. The dangerous situation most people ignore. There's one situation where hair dryers become extremely dangerous: using them near water. That's why modern hair dryers include shock protection systems. Many newer dryers have GFCI plugs. These are the same safety devices used in bathrooms and kitchens. If electricity leaks toward water, the plug cuts power instantly, sometimes in less than 1/30th of a second. That's fast enough to prevent electrocution. 8. Signs your hair dryer is about to fail. Before a hair dryer fails, it often gives warning signs. Watch for these: burning smell, weak airflow, overheating handle, dryer turning on and off rapidly, loud fan noise. These signals usually mean airflow blockage, failing fan motor, thermostat issues, internal dust buildup. Ignoring these signs can lead to complete dryer failure. 9. Simple maintenance that extends dryer life. The good news? You can dramatically extend the life of your hair dryer with one simple habit. Clean the intake vent once every few weeks. 1. Unplug the dryer. 2. Remove lint or hair from the back filter. 3. Use a small brush or compressed air. This restores airflow and prevents overheating. Many dryers that randomly stop working were actually suffocated by clogged vents. So, the next time you turn on your hair dryer, remember this. Inside that small device are multiple layers of engineering protection working together. Heat-resistant nichrome coils, high-speed cooling airflow, automatic thermostats, thermal fuses, flame-resistant materials, electrical shock protection, all designed to make sure the device doesn't turn into a fire hazard. It's actually a brilliant piece of everyday engineering most people never think about. If you enjoy learning about the hidden engineering behind everyday devices, make sure to like this video, subscribe to the channel, and comment below, what household device should we break down next? You might be surprised how much engineering is hiding in plain sight. And until the next video, stay curious.